Hello everyone, welcome back to a brand new video on the TopSpin software tutorial. In this video, I'm going to explain to you the peak assignment for a carbon-13 NMR and the DEPT NMR. First, let's briefly explain the DEPT NMR. Due to the lack of integration and splitting pattern in a typical carbon NMR, the carbon signals can be difficult to assign. DEPT is a very powerful tool to distinguish between primary or tertiary, secondary, and quaternary carbons to assist with signal assignment. DEPT has 3 experiments that use different pulse angles during the data acquisition process, and they are correspondingly called DEPT 45, DEPT 90, and DEPT 135. The last one is the most frequently used DEPT experiment. In DEPT 135, primary or tertiary carbons are positive, secondary is negative, and quaternary carbons disappear due to the lack of attached protons. Since both primary and tertiary carbons are positive in DEPT 135, how can we distinguish them? Well, the COSY and the HSQC NMRs that we previously covered might be helpful. Additionally, you can use DEPT 90, which will only show tertiary carbon groups as positive signals. Now, let's get back to our example molecule E80J55 and stack its regular carbon NMR with its DEPT 135. In this stacked version, the spectra at the top represents the regular carbon-13 NMR, and the one at the bottom represents the DEPT 135. The most obvious difference that we can immediately point out between these two spectra would be the presence of negative signals at the spectra at the bottom. Remember, these negative signals in the DEPT 135 indicate the presence of secondary carbons CH2 groups, so these signals should come from the carbons C, F, G, A, and H from our compound E80J55. However, the DEPT 135 NMR alone does not provide us with sufficient information on which carbons should be assigned to which signal. For this reason, we need to look at additional spectra such as the 2D NMR HSQC. You may refer to the videos 7b1 or 7b2 previously uploaded in this channel to get more information on how we can assign carbons to these specific signals using the 2D NMR. Another obvious change that you can observe here is the disappearance of carbon Z from the DEPT 135. Since Z is a quaternary carbon, it does not have the attached protons, due to which it does not appear in the DEPT 135 NMR. All the positive signals that you see here in the DEPT 135 are the primary or tertiary carbons. Now, let us take a better look at the DEPT 135 NMR in more detail. From this NMR, how many primary or tertiary carbons can you find? The correct answer is 4, which are the carbons E, B, D, and I. We made these assignments in our previous video using the combination of COSY and HSQC NMRs. This is the last video in the TopSpin software tutorial series, and it is also the easiest NMR to understand. I hope you've enjoyed watching all these tutorial videos and you find these videos helpful. Thank you so much for watching.